Hi, in this video we're gonna work on exploratory data analysis EDA, which again this is the process to summarize and understand our data. The idea is to gain insights, discover patterns, and to be able to ask questions or formulate some hypotheses about our data. Okay, so the objectives of EDA: first, we want to identify patterns and relationships in data. So you want to find relationship between, like different variables, detect outliers or anomalies that might affect your analysis. Sometimes you want to perform you want to create a predictive model. So if you have some anomalies or outliers, they might affect your calculations. In addition, we want to understand the shape of our data, the distribution of the variables, and finally formulate and ask business questions. Alright, so this is how it looks, a typical process, EDA process. So first we have our raw data. So we start our descriptive analysis, just getting some metrics, some tables. We need to adjust our the variable types. Sometimes when you are importing a data set, either R and Python, sometimes they don't read the variables and they don't assign the correct format. So we need to ensure that we have the correct format for every single variable in our data frame. Then we also need to check where there are missing data, not available. So it is important to make decisions such as, should we do some imputation, and that means I replace the values, or in some cases it's also an option to delete the rows or the columns. That will depend on the case. So once we have our data almost ready, we check for the typical data outliers, and then we start our data exploration. We start measuring correlation between variables. Here it's really important to start visualizing, creating some scatter plots, box plots, and other tools that might help you to identify whether our variables are correlated or not. There are like two big questions here during the EDA. So the first one is, what type of variation occurs within my variables? So you want to understand the behavior of each variable. So it's important to use histograms to check the shape of your data and identify patterns and ensure that what you're seeing in your data matches the real world, the context that you're analyzing. Then the other set of questions are related to the covariation that occurs between my variables, like to check whether they are related or not. That's really important, especially if you want to create a model at some point, like a regression model or classification model. So you want to find some correlation among your variables to be able to use some predictors. Okay, so let's get started with the first one, variation. So this one is related to variability, with the measurement of standard deviation, variance. And in real life, there is variation everywhere. Even if you buy like a bottle of water or a can of soda, in the label you can see the content of the product. But if you measure different bottles or different cans, you will find that they don't have exactly the same value. That's normal, because there is variation in real life for different factors. So the same thing occurs with our variables. Even if you're measuring the same variable, you may get different readings. So it is important to understand the reason of that, if that's just normal variation or if there are other reasons that are causing that variation. So let's get started analyzing variation in one data set. So for that purpose, I'm gonna first load the tidyverse. Then let's use one data set from the tidyverse. I don't recall which package specifically. The name is diamonds. Let's check the variables. So there are around 44,000 observations or diamonds here. So the first variable is the carat, which is the weight of the diamond. The cut, which refers to the quality. Color, clarity, depth, the table, price, which is really important. And then we have some measurements like X, Y, and Z. Alright, so I'm going to get started with the first variable here, carat, which in general it's important in the context of diamonds. So let's analyze using a histogram. So remember ggplot. For ggplot, we require the name of the data set, diamonds, then the mapping, the aesthetics, So x is going to be equal to carat. That's our target variable for the initial analysis. Then let's use a geom histogram to visualize the shape of the diamond, the carat. So please note that most of the carat values are below 3 carats. Some of them are above, but most of them for sure are below 3 carats. What else? You can see like most of the diamonds are small, like below 0.5 carats, right? And you can play with the bin width. We can change it if you want, like make it smaller, make it bigger to see different analysis. So let me show it to you. So the bin width, here we use it depends on the variable, right? Because in this case, the variable is carat. So if I use 0.5, it's going to take the size like from the 0 to half. So to this part. That will be the size of the bin. So they look bigger now that I change it to 0.5. The shape looks similar. Okay, so let's say that we're going to analyze like the smaller diamonds, those that are less equal than 3 carats. So let's do that. I'm going to create a new data frame. Here is a table. So smaller. So we take diamonds, we use a pipe, and then we filter carat variable less equal 3. So now we have the new table with those carats, with those diamonds that are with carat values lower equal 3. So let's visualize that plot. Is going to look the same, pretty much the same thing as the previous one. I'm just going to copy and paste. We just need to change the name of the data set because we're using the table smaller. See it? So we're getting a similar histogram. I'm going to decrease the size of the bin width just to see if I can find, like some patterns, some behavior. Okay. Now that I'm using a bin width of 0.01 carat in this case, I can see something different. We have like peaks, and then the frequency decrease, and then there is another peak, and then the frequency again starts decreasing. So when we check the x-axis, so what we can see is like the peaks are like in 0.5 carats. For example, here this is 0.5 carat, 0.25, I'm sorry, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75. Here we have 2. I'm sorry, this is 1.5, this is 1.25, this is 2 right here. So if you notice, we have like the higher amount of diamonds that are either in the exact value, like 1, 2, or as a fraction of some specific fractions, like 0.25, 0.5, 0.75, 1, 1.25, 1.5. So that's why we see these peaks here. Maybe that's the way the industry works. They try to create diamonds around those like specific fractions. Maybe like to have like a 0.33 carats is not a standard thing to do. Again, I'm not an expert here, and that's normal. We're speculating here because we're not familiar with the context. But most of the times when you're doing an EDA, it is expected that you know the context, that you know your company, you know the information that you're working with. So your initial insights and the hypotheses that you're going to create are going to be like higher quality hypotheses because again you're familiar with the information. Okay, so let's continue with our analysis. Now let's check covariation. So covariation, the idea here is to check the relationship with other variables. So we need to start using like some scatter plots, even box plots. Here we can, at the same time, put 2 or more variables just to see if we find relationships or patterns. So the first one is, let's explore how the price of the diamond varies with its quality. So the variable that measures the quality is cut. Okay, so for that purpose, I'm going to use a box plot. So ggplot, smaller, that's the data set that I'm using now. Statics, x is going to be cut, and y is going to be the price, because we want to check the relation between these two variables. What is the initial expectation? Well, I guess what we will expect is like the price is going to be higher for those cuts of higher quality. That will be our initial intuition. So let's see. Now let's create a box plot, Gion box plot. I'm missing an O here. All right. So now we have the box plots. They look pretty much same, aligned. Maybe the median, it's different in some cases. Remember the thick line inside the box, it's the median. So it splits your data in two parts, like 50% of observations are above the median, 50% of observations are below the median. So in this case, maybe you will find something a little bit surprising. It's like, if you notice the median, it looks a little bit higher for the fair cut compared to premium and ideal. And these two are supposed to be like higher quality cuts. So this will be my first question. This will be in the homework. Like, try to find why the fair cuts are having like higher prices compared to the premium and ideal, which are supposed to be higher quality diamonds. So that question is going to be in the homework. My advice here is that you should start analyzing more variables. Add more variables in your analysis so you can answer the question. Okay. We can explore the, please notice that here in the box plots we're using one numerical variable, price, and one categorical variable. The fair cut, this is the cut, it's a categorical variable and these are the levels of the variable. Fair, good, very good, premium, and ideal. But now, in the second question of this part, we were going to try to compare or analyze two numerical variables, price and carat. So here it makes sense to use a scatter plot to see if there is some sort of relationship between them, if it's linear or non-linear. So let's create a ggplot. The mapping. So for x, let's use the carat. I want to see the relationship with the price. And let's create a Gion point. I think you remember this one, pretty sure. It's just a scatter plot. Alright. So what we get, it's a plot with, yeah, you can see some trend here. And it makes sense, of course. If the carat size is increasing, then the price is increasing. We see a lot of variability, like the variability is increasing after like the carats, diamonds with carat greater than 1. The variability it's increasing a lot. And also you gotta be mindful that here we have a lot of points because there are like 54,000 observations around that. So we have like some overlapping points here. So it is possible to add more parameters into our visualization to kind of like have a better understanding of the number of points. So one possibility here is to add one parameter that is called alpha. So I just copy and pasted the same code for the previous plot, but now in Gion point I'm going to add the alpha. This is a transparency parameter. So in the areas where there are like few points, the color is going to be light, and if there are a lot of points, it's going to be darker. So now you see like there are a lot of diamonds, like small diamonds here, and that's expected because remember when we were analyzing our histogram, so most of the observations were, you know, carats below 1 carat, right? Diamonds below 1 carat. So now you can see that. So we have a higher concentration here, and we have like a few number of points after 1 carat. So this is one option, and it is also possible if you like box plots, because box plots are useful. They give information about some like key statistics such as the quartiles Q1, Q2, Q3, and at the same time you can see outliers. If there are points that are like above or below the whiskers of this box plot, then those are outliers, observations that are behaving in a way that it's way different than the other observations in your data set. So let's try to create a box plot for these two variables. Initially we're going to get an error because carat is a continuous variable, so it's impossible to create like one box plot per point. That's going to be a mess, you know, like 54,000 box plots here. That's not a possibility. So let me show it to you real quick how it looks. So let's create ggplot using a smaller aesthetics, x equal to carat, y equal to price, plus g on box plot so we get a single box plot, right? It's not giving us a lot of information. But if you notice, there is a warning message here. It says, oh, this is a continuous variable. So maybe did you forget, it's asking, did you forget to use to group the informations, the observations? So it's possible to create some groups so we can have multiple box plots here. So let's do that. So in GeoBoxplot, I'm going to create an aesthetics. This is for continuous variables. Again, if you have a categorical variable, that's fine. You won't have to add this additional parameter. But if you have a continuous variable, then you need to create groups to split the values of the variable. So let's do that here. So with the parameter group, so we're going to create the groups based on the width of the variable. This is another function called width. Now we provide the name of the variable that we're using to create the groups. In this case, is carat, right? And then we need to make a decision of the carat size to cut the groups. So here I'm gonna use. You can try different values. I'm gonna use like 0.1 carats. So every 0.1 carat is gonna create a group. Let's check the result. There you go. Now we have like one box plot for every 0.1 carats. So this is 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, all the way from 0 to 3. So we are getting like multiple box plots again. What it's doing is just taking groups of the carats that of the observation that have the same carat value, but it has to be in those values of 0.1, 0.2, 0.3, 0.4, because we're using 0.1 as the cut width. And the interesting thing here is that we can check that there are some outliers, especially in some areas, and then you can like dig deeper to understand what's happening with those observations in those carat values. Okay, I'm gonna stop the recording for here. This is our first EDA. It's a basic one, but we're gonna keep increasing the complexity of the EDAs by adding more tools, more analysis. Hopefully you will start getting like more insights from your data. I'll see you in the next video.